Hi everyone, welcome to Riot Games at the Edge. My name is Ashwin Raghuraman, and I'm a solutions architect at AWS for the past 4 years, and I've been supporting Riot since last October. Since 2011, I've been a huge Riot esports fan, been playing League of Legends since Season 1, and I have a huge interest in game tech services, our media broadcasting services, and edge technologies. So super happy to be here with you guys to talk to you about some of the cool work we're doing with Riot.
Hi, I'm David Press. I'm currently the tech lead for League of Legends at Riot. Previous to this role, I was the Riot Games infrastructure platform tech lead, which is where I did all the work for this presentation. And then previously to Riot, I was a developer at CCP Games, where I was the tech director for the unreleased World of Darkness MMO. So let's go into a little bit who is Riot Games, a little bit about our company. Our mission is we aspire to be the most player-focused game company in the world. This is something we're always working towards. We know we're not there yet, but this is our kind of North Star. We're over 3,000 Rioters. We're spread over 20+ global offices around the world. And the main game that we started off with was called League of Legends. It was launched in 2009. And it's a team-oriented strategy game. It's a kind of you're one player playing with 4 others against another team of 5, and you choose one of over 140 playable characters called a champion. It's set in a modern fantasy world, and it's been a real big success. We're happy to know that it's one of the most played PC games in the world. So Riot Games isn't only the League of Legends company. 2020 was a really big year for us with new products. In the beginning of the year, we launched a new collectible card game called Legends of Runeterra, also set in the League of Legends universe. Shortly thereafter, we launched Teamfight Tactics on both PC and mobile, and that's in the auto battler genre. And then in the middle of the year, in summer 2020, we launched Valorant, a tactical first-person shooter, which we'll be going into a lot today. And then finally, at the end of 2020, we launched Wild Rift, which is League of Legends kind of reimagined for the mobile platform and eventually console. And then this year, just a few weeks ago, we launched Arcane, which is an animated series set in the League of Legends universe, launched on Netflix. So let's go into Valorant a bit. It's a character-based tactical first-person shooter. What we mean by tactical is it really emphasizes kind of precision, gunplay, your skills, your ability to work with your team. And then it's also character-based. And what that means is you choose one of over 16 different agents, we call them, which each one has a unique set of abilities they bring to the table. It's a bit different than your normal tactical FPS, where everyone on your team basically has the same abilities and can do the same thing. Valorant has also been a great success. We have over 14 million active players spread all over the world. So let's take a look at what Valorant looks like today.
You've earned this win. Let's make it official.
Think you can live up? You got this!
You think you can kill me?
Last player standing.
Over here. Push forward.
Keep up. You got this.
하나 끊어냈고요. 하나, 둘, 두 명째, 세 명까지.
I have a feeling the swirl is about to go colossal. There's one. Yakuza tearing to find the tree. And there it is.
Don't worry, guys. I got this.
Wow, that's pretty hype. I kind of want to go play right now. So let's go into Valorant's design goals, because they really play into what we had to do on the technology side to make the game a reality. The first thing is Valorant is a really competitive game, and competitive integrity is something that we had to make sure that we were really focused on. And so that means we want games to be fair. We want a team and a player to be successful to the extent that they're the most skilled, that they work best with their teammates. We don't want people to have any advantage based on any sort of cheating that they do, or any other. We wanted every other design element in the game to really accentuate people's skill. Along those same lines, we want to support a wide range of setups. We aim to be a very global game, and so not every part of the world can afford a top-notch rig to play this game. And so it kind of goes back into the competitive integrity. We don't want you to be successful because you spent the most money on the best hardware. We want you to be able to be successful purely based on your skill. We want movement to be smooth and highly responsive. As a tactical first-person shooter, you want everything to feel really nice. You want, and again, going back to the fairness, you don't want a little hitch or a little bit of latency to mess up your ability to hit your target. And so getting that to feel really good was incredibly important. And then we want gunplay to just feel rewarding. We want to really make sure that ultimately you win and lose based on how precise you can be hitting the other characters. And it just needs to kind of feel real good, the responses, the sounds, the visuals. And then really pertinent to this talk is we wanted to give players holding territory an advantage. That means in the context of this game where we have a kind of plant and diffuse bomb mode where you want to, where one team is trying to plant a bomb in a certain area of the map on the other team's side. We wanted the team defending, trying to keep the other team away, to have a bit of an advantage so that when they're sitting there waiting for the other team to approach, they can kind of get the first shot off. And it's actually really tricky to do in these types of games where kind of the laws of physics and latency can really make this difficult. So let's go into that. So there's a concept kind of popular in this community called Peeker's advantage. What that means is when you're kind of going around a corner, you actually see the person on the other side of that corner before they can see you. So you kind of follow this animation, you can see that the person on the left going around the corner actually can see the player and thus react to them more quickly than they can see the person going around the corner, and thus actually the peeker has the advantage instead of the holder. So let's go into why that's the case. So it kind of comes down to the fact that when in a client-server game like Valorant is, the client is moving and then needs to send out those movement packets from the client to the game server. The game server needs to process those packets and then send them along to the other players. And so when the peeker goes around the corner, they can actually see the holder before the movement packet gets all the way to the game server and then from the game server to the holder, thus kind of giving them that peeker's advantage. So this goes into a little bit of the timeline view of this. What you can see here is that the peeker does their movement, sends their packet to the server's processing it, sends it over to the holder processes it, and then there's this kind of dotted line for both the peekers and the holders' reaction times. So this is actually a key piece of where we can combat the peeker's advantage if we can put enough technology and design into this. So because of the kind of psychological human element of this, the holder's reaction time is usually, in all things being equal, faster than the peaker's reaction time, because they're standing in one spot, because they're kind of expecting the peaker to come around the corner. Their brain can kind of register that they need to shoot before the peakers can, because the peaker is kind of actively moving, and we actually have pieces in the game that make it difficult to aim while you're moving. And so the peaker has to actually stop and then shoot. So this gives us some wiggle room where if the time for the peaker to send their packet to the server to process it and then send it along to the holder is lower than the difference between the holder's reaction time and the peaker's reaction time, then we can actually give the holder that advantage. The problem is that that time really needs to be compressed to make up for the difference. So this is what it kind of looks like with different amounts of latency between the client and server. At 141 milliseconds, you can see that you can kind of see a lot of the holder before they can see you. With 101 milliseconds, a bit better. At 53, you can almost barely see the holder. And then, what we really want to do is get even lower than that, and then you can't see the holder at all before the holder sees you. So we did a bunch of tests like those photos before, and what we determined was we really wanted to keep things under 35 milliseconds. If we could get 90% of players within a certain region under 35 milliseconds, we think we can really hit our goal of the holders kind of having the advantage, the defenders, and then that can really lead to a whole different type of gameplay that we can get out of the tactics in Valorant. So there are kind of two ways to bring that latency down that we could come up with. One was to move game servers closer to players. So the closer you can have game servers to players, the less distance those movement packets need to travel from the client and server. That always helps. The other way to do it is to kind of improve the routing between the client and the game servers. And so if the client movement packets are bouncing around the internet, taking the long way to the game servers, then it doesn't really matter if the game servers are closer. So we want to make that as straight of a path as possible. So, to really hit our targets, a very ambitious target of 90% under 35 milliseconds, we really needed to do both of them. And that's what we're going to go into today. So first, let's focus on moving game servers closer to the players. To do this, we really needed to go with a lot of different options, a lot of different strategies. Our first one, really our most preferred one, was to use as many of the AWS regions as possible. AWS has a great presence all over the world, and it's kind of the easiest way for us to stand up new infrastructure really quickly, to handle the extra launch capacity, to the elasticity that you get from being in an AWS region. Really helps us handle launch and scale up, scale down as we need to. But that wasn't enough. What we really needed was to get into other locations that AWS didn't have full-fledged regions for. And so that's where AWS Outposts came in. AWS Outposts are basically an industry standard rack that you can kind of roll into a location that you've leased. All you have to do is have that location leased out. You need some power and cooling constraints met, and then AWS kind of takes it from there. They roll the racks in, they ship them, they set them up, they connect them to your WAN, and then it looks almost exactly like a normal AWS region that you can launch EC2 instance into. You can kind of see it in your console, and you can use all the same Terraform and other tools to interact with it. And so this really allowed us to fill in a lot of the gaps that we had from the AWS regions. So AWS Outposts are kind of a subset of the products that you can get from an AWS region. It's these available right now, and there are more coming online all the time. And then for Valorant game servers, it really provided everything we needed. And finally, we couldn't get AWS Outposts in every country that we wanted to kind of have a presence in to meet our latency targets. And so that's where we also had to use Riot data centers, where we set up our own Metal, put together our own networking, and had our own automation to interface with it. This was our least preferred option because we couldn't use all the same tools that we could use in AWS, but it was there as kind of the final option of last resort. And so we really had to combine all of these. We couldn't just do Metal, we couldn't just do Outposts or just regions. All three of these together really combined to give us as much coverage as we could get. So let's go into kind of how we applied this to the Valorant deployment timeline. Valorant was launched in June of 2020, but a private beta actually started in April. That gave us a few months to really collect a lot of data from real players around the world of like how they were playing Valorant, how many of them there might be, and more importantly, where they were and what their latency was to the various locations we had. At that time, we didn't have any outposts. We just had regions and a few Riot data centers. And we kind of had an assumption that that would hit our targets. We did a bunch of analysis before launching Valorant that we thought that would be enough, but kind of reality hit us in the face as we got in front of real players with kind of their real distribution around the world. And so as soon as we started collecting data in April, we realized we weren't going to hit our targets. And in fact, we were pretty far from them. And so that's where we approached AWS and said, hey, we need new locations quick. Can you get outposts in these places? And we only had a few months turnaround time to make this happen. And so we got that going. We did all the testing, and we actually were able to start deploying these outposts in June and July, and then we were done with our first set of outposts in August, in which case we were able to start, we really saw the improvements that we wanted to get out of them and could really start working on that other strategy of optimizing our routing. So let's take a look at North America region to get a sense of kind of where we needed to put these outposts and kind of what the gaps were. So when we started the private beta, we were using 3 AWS regions on the East Coast, on the West Coast, and then we had a Riot data center in Chicago. If you kind of look at this map, you can see there's some big gaps where there are a lot of players in the United States. Texas and Florida being kind of in those dead zones. And so when we looked at the latency from those players, it was definitely not at our 35 millisecond target. And so we decided we could put outposts in those kind of areas in Dallas and then Atlanta. And then the results were quite a bit better, 20 milliseconds for Texas players, 26 milliseconds for Florida players, really big improvement. Let's take a look at Europe, where we kind of had similar gains. When we started off the private beta, we were using regions in France, England, Germany, and Stockholm, and then we had a Riot data center in Istanbul. Again, looking at the map, there's some big gaps, especially in the West and in the East. And so we decided to put, if we had players in Spain or in Poland, the results for them were not quite where we wanted them to be. And so we added outposts in Madrid and Warsaw, and now the latency is much, much better. So let's kind of see how all these improvements stack on each other. Before the outposts, we had 69% of players under 35 milliseconds. Remember, our target was 90% in North America. When we added the Dallas outpost, huge gains, around 8% more players were able to get under 35 milliseconds. And then, thinking about this is across all 8% of all North America players, not just Texas players. And then when we added Atlanta, we brought an additional 4% of players in North America under our 35 millisecond target. If we look at EU, we were at 68% of players under 35 milliseconds when we started. When we added the Warsaw outpost, we brought another 2% of players under 35 milliseconds. And then when we added the Madrid outpost, another 6% of players under 35 milliseconds. And there we were at a target of 76%. Still not quite at 90% as we wanted to in both the regions. We're definitely getting closer, but we needed to improve things even further. And so we've kind of talked about moving game servers closer to players. Now we need to go the next step and improve routing from our players to our game servers. So to kind of go over what the problem is that we're trying to solve here, when you look at the way kind of the normal internet works, if you have a player, say in San Jose, playing against game servers in Chicago, you have their packets kind of coming from their computer, going over their ISP's network, and then their ISP, as soon as they can, kind of hands off that packet to other networks. And so those ISPs are actually incentivized to get those packets off their network as early as possible. The more stuff's on their network, the more kind of hardware they need to purchase to accommodate for. And so then those packets kind of flow to different networks. They eventually get to their target, but it doesn't necessarily take the most optimal path to get there. It might bounce around, go to Denver first, go down to Dallas, and then to Chicago. And then if something goes wrong anywhere in that path, it might have to reroute and go a different way. Say there's maybe a DDoS in LA, and that makes it reroute and have to go a completely different direction. And so what we really wanted to do was make that a straight line. The less stuff that's in between, the less hopping around you have to do, the less latency you're going to get, and the less things that can go wrong. So that's where we built a product at Riot called Riot Direct. Riot Direct is basically our own internet backbone. It's comprised of routers we place in strategic locations around the world, and then we connect those routers both to each other and to ISPs in each of those locations. And so we'll peer with ISPs like Comcast or Cox or all the popular ISPs around the world. And what that means is we're going to get packets from the players on those ISPs onto our network as soon as possible, and then we follow these cables that we've purchased that are basically as direct as possible, as low latency as possible from our routers to our game server locations. And so, when you have packets being handed off to other networks as soon as possible, like in the normal ISP use case, it's kind of called hot potato routing. You're trying to get that away from you as soon as possible. For Riot Direct, we really want cold potato routing. We want those packets on our network, and we want to hold on to them as long as we can. We use a technique called Anycast networking, where basically a game server with a certain IP address, we actually advertise that IP address across all of our routers, and then that gets advertised to the ISPs that we peer with. And so what that means is that attracts the packets from those ISPs to the closest router that that ISP is connected to, gets on our network as soon as possible, and then we send it off to our game server locations. So this is kind of what the Riot Direct map looks like today. You can see we've invested a lot in having locations all around the world, lots of cables, lots of redundancy to make sure that the routing is as optimized as possible. And we're constantly adding this. We're looking to add locations in Middle East, more in India, and eventually in Africa as well. So Riot Direct is kind of our attempt to really tackle this problem. But since we were using AWS, and AWS has their own edge network and their own backbone, why didn't we use that? Like, what does that bring to the table? For that, I'll hand it off to Ashwin.
Thanks, David. I can take that one. We do. So AWS Global Accelerator is a networking service that improves the availability and performance of your application traffic using the AWS Global Network infrastructure. When the internet is congested, AWS Global Accelerator optimizes the path to your application in order to keep packet loss, jitter, and latency consistently low. No matter where your users are located, Global Accelerator intelligently routes your users' TCP or UDP traffic to your application endpoint on AWS that will give you the most consistent performance. Global Accelerator provides a set of static IP addresses to use as a fixed entry point to your AWS application. Announced via Anycast and delivered from AWS edge locations around the world, these eliminate the complexity of managing IP addresses of multiple endpoints and allow you to scale your application and maintain DDoS resiliency using AWS Shield. On the back end, you can add or remove AWS application endpoints such as application load balancers, network load balancers, EC2 instances, and even Elastic IPs without making user-facing changes. In fact, Global Accelerator allows you to serve internet users while keeping your ALBs and EC2 instances private. It also monitors the health of your application endpoints and will automatically detect unhealthy endpoints and redirect traffic to a healthy one in less than a minute. So here you can see a map of the AWS Global Network. This is a network of 100 gig links with subsea cables that span both the Pacific and the Atlantic. And they're built to carry only AWS traffic, and AWS customer traffic is actually prioritized. As you can probably tell, there's different geographies here that are covered by Global Accelerator, where Global Accelerator is actually a little better than Riot Direct in those regions, and conversely, Riot Direct actually has some regions where it's better than Amazon Global Accelerator. So this is going to play a little bit of an interesting role in Riot's strategy. So how does Global Accelerator work? Typically, when you have an application deployed in a region and users that are geographically distributed, traffic needs to ride the public internet to reach the destination. Instead, with Global Accelerator, you can use the globally advertised Anycast IP addresses, which allow your packets to ride the AWS backbone even in cross-region scenarios. In Riot's case, the Valorant matchmaking system selects players that are geographically close to one another, so this scenario is never really seen for Riot, but nonetheless, it's an important performance increase that Global Accelerator can provide your applications. So let's talk about a use case for games. So traditionally, if players are connecting to game servers in AWS regions, they need to talk over the public internet and use port ranges that are exposed for certain game sessions. On the other hand, with Global Accelerator, you can have players connect to the Global Accelerator endpoint with a destination port. AGA will then route the packets over the network backbone to the correct instance. There's actually 65,000 ports that are available, and you can configure any of them for use on Global Accelerator. So now I'll hand it back to David to talk us through the network optimizations Riot made using Global Accelerator and Riot Direct.
Thanks, Ashwin, for giving us that overview of Global Accelerator. So we have this kind of choice. I talked to you about Riot Direct. Ashwin talked to you about Global Accelerator. We have both of these options. So which one did we end up going with? Well, both. Really, to hit our targets, we had to combine these two technologies because really they each have strengths in different parts of the world, and we really needed to overlap them in even similar parts of the world to really get the results that we needed. So let's take a look at how we combine these two to get better results for our players. So if you have two Valorant teams, they're on the left, they've decided to play a match together. What they first do is they kind of send some latency tests across each edge network. So in this case, they're going to try out Global Accelerator. They're going to try out Riot Direct. And in this case, you know, based on where they are and how the internet's doing today and like where Riot Direct strengths are versus Global Accelerators, they decide to go over Riot Direct. That's the best for these 10 players. And they play on kind of the Riot Direct game servers. In another situation, maybe on another day, these 10 players try out Riot Direct. They try out Global Accelerator. And then in this case, Global Accelerator is doing better. And so they play on the Global Accelerator game servers. So this was great. It really improved, you know, by choosing the best one for the particular 10 players, we really get a lot better results. However, there were some tricky bits of getting this working. One issue is that we have to have different game servers for each edge network. And that's tricky because you know, as I was saying, depending on the day, one edge network might do better than another, and that means some more players might be playing on one or the other, and that'll change over time. So we really had to kind of optimize our capacity management for these two game server pods to make sure that we had the right amount of capacity available, depending on what the internet was feeling like that day. But recently, we've actually improved that. Just in November of 2021, we released it so that we can have a single game server pool, and in this case, the players kind of pick whichever one is best for that individual player, and then those are both connected to the same game server pool. This leads to even better results because we don't have to force all 10 players on the same one, even if some of them are better, but they might be in the minority. We have to pick the other one. In this case, we can pick the best edge for that individual. So we did some analysis to see kind of what the impact was of combining the two edge networks instead of just picking one. And in North America, we saw kind of modest, but still impactful, an additional 2% of players under our 35 millisecond latency target by, again, combining Global Accelerator and Riot Direct instead of just picking one. In EU, we got better results. We were able to add an additional 4% of players under 35 milliseconds. And then in APAC, a staggering 22% of players under 35 milliseconds just by combining them instead of picking just Riot Direct or picking just Global Accelerator. So if you bring this all together and say EU, we had 68% of players under 35 milliseconds before we added any outposts. We added Warsaw and got to 70%. We added Madrid and got to 76%. Then we did all those optimizations, bringing on a Global Accelerator, bringing on Riot Direct, and then combining them. And that brought us an additional 9% of players under our 35 millisecond target. So we're really close to 90%, which is our target, but we're not quite there. We're still doing work to optimize routing. We're looking at new locations we can add to get under that target. But we're definitely much better than when we started. So what have we learned from all this? It was really important for us to have a meaningfully long beta timeline. By launching the game in April, or launching the private beta in April and not launching the full thing until June, we had a decent amount of time to collect data, to build a new plan, and to then start executing on that plan. And we started making meaningful improvements throughout the beta timeline and then shortly after launch. It was really important that the beta is kind of representative of real traffic. If we just did a North America beta, we would only learn about what we needed to do there and not in Europe or in APAC. And we really needed to make sure it was as widespread as possible, because ultimately these optimizations are really local to certain parts of the world. You can't just look at one part and think that what you do there will help everywhere. And then finally, it was really important to be flexible. It's really tempting to just pick one strategy or another, to just invest in AWS regions or just invest in Riot Direct instead of Global Accelerator. It's certainly less work, but what we found out is we really needed to combine strategies to get to our targets. It's a lot more work, it's more complexity, but ultimately it's where we needed to go to serve our players best. So thank you very much for watching our presentation. On behalf of Ashwin and I, we really appreciate kind of giving you an insight into how Riot Games launched Valorant. You can reach out to any of us on LinkedIn, and thanks for watching.